All right, welcome back to Meteorology 101. Visit my website, meteorology101.com. Got a lot of information over there if you want to learn about weather. So, I'm going to start this live stream with the SPC put out the latest updates today. This is the hail, probability of hail. So, we're in the yellow in Oklahoma with a 15% chance of hail. If there was a hatched area, it would be a 10% or greater probability of 2-inch hail. So we don't see anything hatched. We don't have to worry about that. I'll go over to the Thunderstorm and Tornado pages. Here is the probability of thunderstorms. And we do have a slight risk in Oklahoma, where pretty much where that hail was forming, because you pretty much need hail to create the static electricity you need to create lightning. Once lightning strikes, makes a noise, you hear the thunder, that's when the thunderstorm starts. Tornado probability, we are basically 2%. I guess there's always a slight chance of a tornado in those areas. Not likely in December, but after what we've seen last Friday, anything's possible. So, still 2% chance for tornadoes associated with those thunderstorms. Go to the latest current radar loop, and we can see a little bit of convection in that area. We'll get into a local radar here in a few. Looks like some convection in the Missouri, and then the precip stretching all the way up into the Ohio Valley. Maybe some mixed precip in northern Indiana, and then we have our snow showers up in the Dakotas, up in the north central U.S., and that's going to be pushing through. They should be getting some pretty good accumulation up in that area with everything that's been going on the last couple of days. And then the northwest is still getting wet, some snow. Then it looks like the radar's just kind of picking stuff up off the coast. So here's a local radar. This is for Ohio. Let me pull up the warnings, see if there are any warnings out. We have two severe thunderstorm warnings in Oklahoma: Carter, Jefferson, and Love County, and Cole, Hughes, Pontotoc, and Seminole counties. We'll go to those locations, download the latest loop on that. Alright, so these are the areas for severe thunderstorms. We do have some 60 dBz reflectivities in that cell, and also to the south. So this is like a pretty decent cell right here. Let's do a cross section on that, see if we can catch something. Pretty good reflectivities, almost 50 dBz's up to 25,000 feet, 60 up to 20,000 feet. So that's a pretty good cell, but it's vertical. It's pretty vertical on that updraft, so that's why there really doesn't look like any tornado threat just yet. Pretty much need some tilt to be able to start getting your updraft going at a tilt, then enough precipitation falling out to get a downdraft and create the vortex. There's a pretty strong cell here. Nothing in the severe warning area yet. Cross section that one. Still vertical. Pretty intense. 60 dBz's, almost to 20,000 feet. Just a small area. Do a volume scan on that real quick and see if there's anything. Look for some rotation. A little bit of rotation in that cell. Let me get back in there. All right, let me get a get to the 50 dBz. Pretty much breaking up pretty good right there below 20,000 feet. But we do have 50 dBz's on a strong, pretty strong in those upper levels. So here's the 3D scan of the velocity. No real rotation through that storm. So once the radar indicates rotation, then they'll put out a tornado warning. But that cell looks like it's starting to build up pretty good. Go check this one out. Do a cross section on that. So 60 dBz's up to about 20,000 feet. Got a little bit of tilt going to that, but nothing, probably no rotation indicated by radar just yet. Let's go to a base velocity. I'm seeing rotation there. Let me see what we got. Let me go 3D scan on that one. Got a decent little tilt on this thing, so that would be one to watch out for, a possible tornado warning coming out there. Throw 40 to 50 dBz's, kind of shadow that. Let's get a little bit bigger shot of this thing. Let's look at some rotation on that one. I mean, I'm seeing some pretty significant rotation through that storm. I'm surprised I don't have something out on that yet. Here's the velocity scan. You can see where the green comes in. We'll go to a base velocity. We look for our radar. It's up to the northwest from that, so the darker colors are out. So typically the wind's blowing from the southwest, but the green's into the radar. So we got some areas that looks like some rotation in this area. So like I said, I'm surprised they're not putting anything out on that. Almost 1-inch hail indicated by radar. Get a better shot of that one. Get rid of that. Probably got zoomed in too much now. I'll go back here, get my base reflectivity. There's our 60 dBz. Pushing 10,000 feet. Definitely got the tilt, so like I said, wouldn't be surprised if a warning doesn't come up right there. There's another little curvature on this cell to the north of that. Let's go see what's going on there. There's the 50 dBz, kind of it's up to 10,000 feet. You know, that's all you really need to have a severe thunderstorm. Once you have You got the 10,000 feet, 50 dBZs at 10,000 feet gives you a potential for a severe thunderstorm. You can have winds come to the surface and create the winds you need, or this thing could produce hail up to an inch and cause that to become severe. I'm starting to see a 60 dBz in there also. Let me turn that off. Now you can see, without smoothing this thing, you can definitely see starting to build up in that cell. Alright, let's go look at the satellite real quick. Alright, you can see the convection through Oklahoma, pushing all the way up into, looks like, Missouri. All the brighter clouds are higher clouds, and then Cirrus overshooting that ridge. You can see the rotation, high pressure system pushing warm, moist air on shore. We have to see if we got a low pressure system here, if there's a major shortwave, a minor shortwave, something causing this. And then if you see the ridging up in the northwest, looks like possibly that jet stream has a long wave trough, and then pushing up through right behind the frontal system. That's probably the remnants of that front that went through. Let's go. I guess the convection starting right there in. Just trying to zoom in. It's Alabama also. Starting to shear off, it looks like, so that probably won't end up being anything. Got some stuff in the Gulf. See if that survives to the Florida Panhandle. Alright, so here's the surface chart. Low pressure system over Texas. Looks like a warm air advection stretching all the way up. Let's throw the isotherms on here, we can see that. Alright, let's get a good look at this thing. We got low pressure. First we got to verify this low. Look for circulation. Let's see, one out of the south, one out of the north, northeast, and then more winds out of the south, kind of all over down in there. Calm. There's a wind out of the northwest. I mean, I can kind of see some rotation right there. Maybe not as strong as it has it on this chart. We need to pull up a thickness chart. We'll place our fronts, but right here we have. Let me clear this out real quick. I'm going to erase this chart, and then we're going to look at the data. Give it just a second to load. Okay, what do we got here? 76. Let me get my pin back on. I'm going to shake the screen on you. There's a 76, 74, 50. So there's probably some sort of front right there. 58, 50, 36. We've got the wind shift right here. Out of the southeast, out of the east, out of the east. That's the indication of the warm front. Then if that low pressure system was over Texas, then we'd have the cold front coming back. And here's our wind shift right here. So we can see that cold front. And then winds out of the north-northeast, placing that low a little bit further to the south right there. So we are pretty close right in the panhandle of Texas. Let's get put the pressure back on. Okay, so maybe move that low just a little bit to the north, just based on our data. Bring the cold front. Probably kind of just shoot right out of that trough. And then we've seen that warm front where those winds are shifting to the east. We got the winds out of the south, winds going to the east. That's your shift to indicate the separation between the warm air and that cold air to the north. So we got our warm sector right in front of that low. Cold air advection in the back. You can see that on this chart also. Let's go right through here. I see cold air advection. Anywhere these isotherms are crossing, there's the isobars, the pressure and the temperature is perpendicular. You can pretty much say that's your cold air. Some thermal troughing right through here. So bring that cold air pocket right there. So you don't most likely have high pressure behind that with the colder air, more dense, and then with this warm front. We're pushing out. We look for those easterly winds. So that warm front pushing up through the Ohio Valley right there. That's what's causing all this precip. So typically we get in front of the that warm front would be kind of a more of a stable environment, because the warm air would be like warm over cold, so that would be stable, and then you get mostly steady rain through that area. Behind that cold front you would get more of a convective activity like we have in Oklahoma, and then with a more unstable environment right around that low. So, all right, here's the high pressure to the over the Atlantic, and then that's just pushing all this up because the winds rotate counterclockwise around the low, clockwise around the high. So we're just pushing all that warm moist air off the Gulf into the southern states, and we're getting that little bit of convection over Alabama. See the lower ceilings right there in the panhandle of Florida. A little bit lower ceilings all the way up into Tennessee, and then you get close to that warm front. That's where your ceilings and your visibility drop. So we got 6 miles vis. A little hard to read this thing. 700-foot ceiling in Illinois. So our ceilings are dropping. Low, very low clouds, stable, mostly like stratus clouds in that area. Low ceilings and IFR conditions. So we'll have to see how this low develops. We'll go to the models. Let's see if we got anything in the upper levels. It's just showing it's closed. I'm not too sure if it is a actual closed off low that intense just yet, but we can go to the 850 and see what we got. Let's pull a thickness chart real quick first though. See what this computer generates as a thickness chart. Let me erase that. Takes a little bit to process that data. Plus we're going to look for our 540 line on the thickness chart. We can kind of place our jet too. So we was looking at that satellite thinking maybe we had a long, deep long wave trough in the southwest. This thing's just putting a big cold pocket right in the center of the U.S. Let me go get out of there. I don't think that 540 line is that far south. I think this is over exaggerating that cold air behind that low. Let this thing finish first. Alright, so this one's showing our 540 line coming out of the north and then dropping down all the way down to Kentucky and North Carolina. So you can follow that along right there. That's our rain snow line. Basically one of the first things you look at on a thickness chart, see where your snow is going to be. Anything north of that should be snow, but this obviously is not the case. This is rain. If we go back to the radar, we can see that, but so this data is just kind of incorrect. Let's go put the sea level pressure on here. Our jet stream though should be, I mean, there's a trough, kind of troughing in this area with that thickness, and then the tightest thickness gradient would be our jet stream, but we're shooting up pretty good, so we do have that troughing, and then there are jet stream shooting through that area, so right through the central US there. So let's get it's pretty much all we're gonna have to see on this chart. So that 540 line's wrong. We can pretty much say that's definitely not snow. Let's get up over here too. We pulled up our radar once to our mixture. Seen some mixture to the northern Indiana. And then definitely in the Dakotas. So we know our thickness line has to come down here, through here somewhere. Probably shooting right through northern Indiana, northern Ohio, for that to be that mixture. So that 500 millibar thickness, the 1,500 millibar thickness is causing the, is right along that mixture line. Alright, let's go back to our charts. Go up to the 850 real quick, see if what that low pressure is doing, if it's shooting up to the 850. And then we'll go to the models, see what we got. Okay, pretty much just looks like ridging off of that high pressure system. Just a big wide area of maybe a trough up here, but I don't think we got a trough there, trough here, and then so we just probably got some minor short waves right around that high. Let me go try a different height. Do two way. I can balance the height on these things, or do just send that in all the data. I got this set up for 3 hours of data now, so we're still ridging all through there, and then trough. So if we had low pressure right there, we'd have a trough with upper level support. So let's go see how much thermal advection we got. There's probably some warm air advection in this area up in the Dakotas that's causing this precip, the instability. Definitely got some thermal advection right through there. These contours are too far apart to be a whole lot of advection if we had anything. Let's go through some data on this real quick, and then we can see what our wind speeds are at 850 millibars or 5,000 feet, and then that'll indicate, you know, if there is any warm air or moist air advection. .30 knot winds, that's pretty good. So we can say there's probably some weak thermal advection in this area, right through here, and then that would be indicating our. So we had a warm front there, cold front here, warm sector. So we're still got that little bit of thermal advection there. We got this thermal advection to the north, right ahead of that trough. So any instability causing these snow showers to the north. This is, like I said, more of a stable environment. And then over to the northwest, maybe some onshore flow in the upper levels, and then causing just a little bit of precip in the northeast. So if we looked at this chart for data, we could look at this should be, man, am I even on? You drawing? Am I drawing on this? You can't even see me drawing, can you? Let's go. All right, here's my draw tool. All right, we got this video screwed. Let's see here. Go. There's our warm front we were talking about. Low pressure system. We were on the surface. We were looking close to the Panhandle, Texas, and then our cold front kind of shooting to the west, just based on our winds and our temperature. So, like I said, this is pretty much a stable environment right here. And then warm air advection in that area, pushing warm air to the north and creating our instability that we need for that precipitation over the Dakotas. So, long wave trough or a major shortwave trough, we have thermal advection even at 850, so that gives that surface low support for development. So we may see that low pressure develop and continue moving to the east. Based on our mid levels, which way it's going to steer, how fast it's moving. So we got 20 to 30 knot winds to the south. So we still got some pretty good, a little bit of thermal advection in that area. So get out of that. Okay. Now to look at this data, we'd have to say any of these black station plots are significant moisture, cloud cover. So we have moisture in those areas, moisture over the west, Southern California, to the north, and we obviously got clouds here. We're just not seeing it on this data yet because this is probably probably not even 0Z data yet. It's probably still early 12Z, the stuff from this morning. Most of the balloons are only let go every 12 hours to get this data. So we obviously got moisture all through here now. So a little tough to see on that screen, but all right, let's jump over to the models and let's get a picture of this low pressure system. See where that's going to go. All right, here's our system. We're in the south central U.S. right now, just looking at this convection. This is HRRR. So this ain't going to go out very far, but it does come with a pretty decent accuracy. Let's go forward on this. We had all that convection over Texas, Oklahoma, so that's pushing into Arkansas. The loop just started over, so this is where it ends, right here. Get my pin up on this one. Got pretty significant convection in that area through eastern Texas, and then maybe that frontal system or the leading edge of that, where that low pressure was, that front, causes some convection all through here. But we'll go back to the local radars and see if we got some tornado warnings or anything yet. Let me pop that up real quick. Get rid of this. We're still in severe territory. We haven't got any tornado warnings yet. Alright, let's go back to the Go to the GFS. Actually, I'm going to go. I want to pull up this the whole United States and see. I'm going to kind of see how that low pressure develops. Okay, so we got our line out of Oklahoma, pushing all the way up toward the Ohio Valley. We know we had that low pressure system on the surface over Texas. Can we see that develop? Let's get a find our sea level pressure. All right, there's that low. Looks like that low pushes south toward the Gulf. Get some pretty significant convection. This is Sunday 03Z overnight, Saturday night. All right, let's go back a minute. So that stuff over the Ohio Valley just kind of breaks up. A lot of precipitation pushes over Maine, the New England states. Probably some more snowfall for them up there. They should have some pretty significant accumulation by now. And then looks like an isolated cell going across North Carolina off the coast. Then that other cell developing over the Gulf, and then shooting across the Gulf into Florida, probably across Florida, and then looks like maybe impacting the East Coast right around Georgia, South Carolina for a minute, and then shooting off the coast. But then Florida's, we got a cell dropping down into central Florida, and actually all the way, another cell dropping down all the way down to the southern Florida and the Keys. So we're before everything pushes off as that system develops. It looks like behind that system, a long ridge, elongated ridge behind the low, and then behind that front, and then we're looks like possibly another low pressure system developing. Let's see. There's another low, looks like kind of like a clipper system pushing through the Great Lakes region. And then some significant convection maybe over Kentucky. That's all they need right now. Looks like more along the mountain range though. So it might be from some upslope orographic lift causing that, any of that convection. Then this gets out to, this is Tuesday, December 28th. So that's, next week after Christmas. We'll get pretty far out there. I don't like going out too far with these models. These things they change daily, and even after like 5 days, they're pretty inaccurate. So it looks like maybe some more convection there through the Ohio Valley. Another frontal system passing through. There's a pretty heavy convection. This is 375 hours out. Sunday, January 2nd. So it'll be a New Year surprise if we get all that convection that we just started over. That's as far as these models go out. I would doubt that. I mean, that could happen, but a lot of this is going to change before that even hits. So if we go all the way back to the beginning, that's where we are now. Alright, so Missouri, this is a 3-hour forecast, and then still getting rain showers through southern Indiana into the Ohio Valley. Alright, let's go back to the real-time data on the radar. There's our line right now through Oklahoma. Flash flooding up into Arkansas. Let's pull up another radar. Okay, so northern Arkansas, flash flooding. Southern Missouri, flash flood warnings. And then we got the severe thunderstorms in Oklahoma still. Waiting for a complete download. Let me get this off here. Just pulled this video up. I was trying to see if there's anybody online. Okay, so pretty good cell developing right there west of Stigler. Let me get a drag tool on here. We can move this around. Let's start analyzing some of these cells. Pretty strong stuff up there in northwest Arkansas. So they're calling these severe. Let me go stop the loop. 0.43 inches of hail. Or 60 dBz reflectivities have pretty much dropped, except for this cell. I mean, this cell, yeah, let's look at the velocity on that. A couple of small red areas there, but nothing significant. Go in the upper levels. There's some rotation. So I don't know why there's not any kind of warning in this area right now. Vertical integrated liquid is there. See what our echo tops are. There's our echo tops at 31, 32, 33,000 feet. So that cell down there. West of McAllister, that's a pretty decent cell. They both look like hail producers based on radar. I know we're only pushing about a half-inch hail. I guess the wind speeds aren't there for severe weather, but I mean, you start looking at 64 knots. I guess more, let's see right there. Really, I guess no significant winds whatsoever. 30 to 34 knots, 29 knots. So nothing significant enough to indicate severe weather. I'd be with the hailmaker right there, and we did have a couple pixels that were kind of indicating some rotation, but not significant enough to be severe. So let's go pull up a cross section or a volume scan on this and see what we got. Sweep that around. There's where the 60 dBz hits. Almost about 5,000 feet or so, and then 50 dBz to 15,000 feet. I mean, it's potential for severe, but it's just not there yet. Let's go catch the middle of that scan. There we go. There's the lower dBz's as we get higher. And then you can see that storm goes up to almost 40,000 feet. Let me get back on there. And you have your overshooting tops almost 40,000 feet. That's the lower reflectivities. Then we start getting into the center of the storm on our higher reflectivities. Once we get to 50 dBz's, that's your significant level now. Do got a pretty decent angle on that storm too. And then 60 dBz. Pretty much anything about 60 dBz at this lower levels, like this, is going to be hail. We have to go and look at our freezing levels. This is right around 10, 12,000 feet, so probably pretty close to the freezing levels. You know, the hail goes up, the water parcels go up above the freezing level, becomes ice, gets too heavy, drops back down, collides with more water. The updraft, as long as that updraft can keep that elevated, that hail just keeps going back and forth above and below the freezing level, and then just continues to get bigger. Stronger the updraft, the bigger the hail, the more severe the storm. So, all right, let's go. I don't know. I don't mind that storm too bad. That's a pretty decent one. They're getting some pretty good rain right there. All right, let's go back. All right, I'm gonna go load a storm. I think I got some saved data we can open. See, I'm not sure what data I have here. We're going to try to load a few of these to the north. This is North Dakota. 2017. See if I can get any cells pop up. I saved some data from this. I think it's from a 2017 storm, but I'm not sure if I got the right loop. There's a lot of data. This program pretty much runs about 24 pages on the loop. So if I get out of range, then I'll miss a lot of the cells that pop up. Looks like a little bit of convection, a little bit of rain anyway, starting right there. Don't think we're going to have anything significant here. Wait till this finishes and then try to catch some more at a different time. Okay. Let's go. All right. Doesn't look like I have too much good data saved here. It's just old ground clutter. 2017, July 11th, 2017, there was a tornado that went through just north of this station. Pretty decent cell with a hook echo. I was trying to find the right timeline on that storm. Let's see, this is 17Z. Let me go back to try to load fewer screenshots here. I'm not having any luck here at all. I see ground clutter around the radar. That's about it. one more time, and then we're going to call it quits. Alright, I'm not seeing any significant weather there. I know there was a cell went through. I pulled that up. Maybe I had lost some files, so I did some transfers earlier. Alright, that's pretty much it. We're going to call this quits. Appreciate watching. Like I said, visit my website, meteorology101.com, and subscribe to the channel. I'll keep some videos going if I get enough subscribers. Let me know what you think.